Straight line. Lesson 8, final lesson. A couple of things to watch out for, plus an example of how things can work together for these kind of exam questions. Firstly, let's consider that we were asked to work out the equation of the line joining the point 37 to 32. By now, in your mind, you should, of course, when you get a question like this, be thinking two things I need: gradient plus a point on the line. I have a choice of points on the line, so step one, work out the gradient. And for a question like this, you'd say gradient, change in y, let's say 7 take away 2, let's do this, take away this, change in x, 3 take away 3, which is 5 over 0. And this sometimes causes a problem, because people look at this and either say, I don't know where to go with this and give up, or perhaps more would say, oh, 5 over 0, oh, I'll just call that a gradient of 5. That is not a gradient of 5. 5 divided by 1 is 5. 5 divided by 0. Well, if you reach for your trusty calculator and do that, it will say something like maths error or syntax error or something. So what's going on here? Well, let's actually consider where the points are. So in a coordinate diagram, just a sketch, this always can help. So let's say this is an x-coordinate of 3, and I'm looking for the coordinates of 3, 2, and 3, 7. So in here I'll say 3, 2 is something like here, and 3, 7 might be somewhere up like there. So there's the line we're talking about. Now, if this is the point 3, 2, then one up that will be the point 3, 3, 3, 4. If this is the point 3, 7, one above will be 3, 8, one below will be 3, 6, down here will be 3, 0. If I keep going way up here, we've got 3, 10, 3, 20, 3, 100, 3, negative 15, down the way, and so on. All these different points here have an x-coordinate of 3, but the y-coordinate can be anything at all. So for once, the equation of the line is not connecting y values with x values. It's just saying the x value is always 3. And the y is not connected in any way whatsoever. And that's because this line is vertical. Vertical lines have equations of this form, x equals. And that's why this equation, to work out the gradient, didn't give me a particular value. Because change in y over change in x, the change in x is 0. It's a vertical line, which this says the gradient, and the technical word for this, which I'm sure you remember now, undefined. And so we don't have a value to plug into y minus b equals m bracket x minus a. There is no value for m, and that's because the y minus b equals, no it doesn't. The y is not connected to the x. Just for vertical lines, we said the formula y minus b equals m bracket x minus a works for almost every line, but not for the vertical lines. Neither does y equals mx plus c because there is no c, it doesn't cut the y-axis. Horizontal lines actually will work. They're of the form y equals, so for example, if this is 0.6, going through here, y equals 6. But that still works here because I can say my gradient is 0, and when I plug that into y minus b equals 0 x minus a, or y minus b equals 0, and then it still works out. So it's only vertical lines where it doesn't work. So watch out, but that's just because the x-coordinate, take away x, we're not allowed to divide by 0. If we say how many zeros make 5, the question is meaningless because it's a vertical line. Second thing to watch out for. If we have a question and we're asked for something like, here's the line, x plus y equals 7, all right, and it says something along the lines of, work out the angle with the horizontal, or work out the anti-clockwise angle from the x-axis, or something like that. Well, angle, we know gradient is also tan theta, where theta is an angle, so we'll say, all right, let's investigate that. To get the gradient from here, I need y equals. So some people would change this into y equals 7 minus x and might say, oh, and the gradient is 7. No, it's not. Because what we should have done, of course, is more conventional order. is to say, yes, take away x from both sides, negative x plus 7. These two things are equivalent. 7 take away x, negative x plus 7, same thing. Oh, but from here, I can say, oh, so my gradient of my line must be negative 1, the coefficient on the x. And that makes sense, because the line is sloping down from left to right. There's no scale on it, so negative 1, maybe it's a slightly different scale on the y-axis from the x. That's fine. So now I take my negative 1, and I say, oh, so if my gradient is negative 1, then tan theta is negative 1. And if you take your calculator and say, okay, I'll do an inverse tan of my negative 1, the calculator will say that your angle we're looking for, negative 45 degrees. Now you need to know what that means in terms of physical diagram. On here, well, you maybe remember from Nat 5, when we were doing angles going round and we said we were solving a trig equation and looking for a second answer, you might have something like all secondary teachers are cool, or however you remembered ASTC. And we said angles were going anti-clockwise from the x-axis, and this was 0 to 90, and then 90 to 180, so that was sine, and so on. Negative answers, like negative 45, right? If this is where we're going from here, that means, well, positive angles go anti-clockwise. This is my negative 45 degrees in there. So how do we write down our answer? Well, it depends what the question is asking. If the question says something like, what is the anti-clockwise angle from the x-axis or from the positive x-axis, then you would say, oh, the anti-clockwise angle going this way, that's this angle they're looking for. We know that this is negative 45, so this angle here must be, what's a straight line, 180, take off 45. So if they ask for the anti-clockwise, we say theta is negative 45, the anti-clockwise angle is 135 degrees. And if you plug tan 135 degrees into your calculator, it will tell you negative 1. Likewise, if you happen to plug tan negative 45 degrees into your calculator, it will tell you negative 1, because in both cases, we're talking about the gradient of the same line. On the other hand, if the question said something like, what is the size of the acute angle between the x-axis and the line, we'd have to say, well, 135 subduce, the acute angle is 45 degrees, but it happens to be 45 degrees below the x-axis. But the little answer to the question is, what is the acute angle? It's 45 degrees. Now, what the exam board do not like is if you just jump from theta is negative 45, therefore the answer is 45. And it looks like I didn't know what to do, so I just dropped the minus sign. So what you can say is negative 45, and then say something like 45 degrees below the axis. And if you put in something like that, that shows that you realize that negative 45 is 45 degrees below the axis. So, as I say, check what the question asks. If the question asks for an anti-clockwise angle, that's this one here. Oh, we'll take our answer here, our negative 45, we'll take the 45 off 180. If it says, what is the angle below the x-axis, you'll say 45 degrees. If it says, what is the acute angle with it, what's the obtuse angle, depends what the question asks, which way we write the angle down. But going from minus 45, if they say they want the acute angle, and you say that's 45 degrees below the x-axis, well, they didn't ask you to say it was below, but that shows that you know why negative 45 degrees gives us an answer of positive 45 degrees. That we're not just dropping the minus sign because we didn't know what to do. And finally, here's a typical exam type question of how the things all come together. And this relates to your notes on page 15. Now on that, can I point out that I'm changing the coordinates of A, B, and C from the ones that are printed on page 15. I think this gives a wee bit of a better illustration of how to do this. So, change your notes, please, so that A is now the point 1, 8. And there's that point in our diagram. B is the point 8, negative 6. And C is the point negative 12, negative 2. These are the vertices of my triangle. And they want to know where the median through A, so that's from A to the midpoint down here, intersects with the altitude from C to the opposite side. So that's that line there. So they're asking for the coordinates of this point here, which looks like it's close to the y-axis, but not necessarily exactly on it. Might be slightly to the left, as the diagram is here, or because it was just a quick sketch, perhaps it's slightly to the right, or on it. We'll work it out. And so, let's start with the median. Median goes from one corner of a triangle, one vertex, to the midpoint of the opposite side. So this down here is our midpoint. I'll put a capital M in there to get that. Two things for the equation of the line: gradient and a point on the line. Easiest way to get this gradient, change y over change in x, which we can do if we work out the coordinates of M. And we know that M is halfway between B and C. So over here, I'm going to say, first of all, let's work out the coordinates of the midpoint. Average x coordinate, that will be 8 and negative 12. I'm working at the average of two values, so divide by 2. Average for my y coordinate. Well, actually, I'm not going to bother doing a calculation here because this is negative 2, and the y coordinate here is negative 6. And I know full well that halfway between negative 2 and negative 6 is negative 4. So I'm just going to plug negative 4 in here directly. You can do a calculation if you want, but we know it's going to work out to be negative 4. So my midpoint, 8 and negative 12, negative 4 divided by 2 is negative 2. Y coordinate negative 4, as we've already said. So that's coordinates of this point here. Quick check to see it makes sense. Is that possibly point negative 2, negative 4? Yes, that's fine. Because midpoint is dividing that exactly in half. Okay. Work out the equation of this line. Well, y minus b, gradient times x minus a, where a and b are the particular coordinates on the line. Y is any y point, so I'll keep the y. X is any point, so I'll keep the x. Plug in values. And for a and b, I'll probably use 1 and 8 from up here. Any point in the line will do. I could have used the coordinates of the midpoint, it doesn't matter. So the y coordinate goes with the y, so that's y take away 8. The x coordinate goes with the x, that's x take away 1. And we've already, we've not done the gradient. We better work out the gradient. So, my gradient for my median is change in y for change in x. That'll be 8. Take away y coordinate down here, negative 4. Over change in x. 1. Take away negative 2. Gradient of my line will be, that's 12 over 3, which is 4. Again, let's check that makes sense. Why it's so often such a good idea to do a sketch. Could gradient of this line be 4? Yes, it's definitely positive, going up from left to right, and it looks like it's fairly steep, even though this is just a sketch, so 4 is a perfectly sensible answer. So I'll plug my 4 in here. Break the brackets and tidy it up into a straight line. Often nowadays, when they're asking for a question like this and they're saying what's the point of intersection, they will actually break it into parts and they will say, give the equation of median AM. So we should give the equation of this line in a standard form, either in the form y equals mx plus c, or in the form ax and by plus c equals 0, where we set everything on one side equals to 0 on the other side, and the a, b, and c, or multiplying the x number and the y number and the c number on its own, are all whole numbers. So y minus 8 equals 4x minus 4. Okay, I'm going to go with, let's set the whole thing equal to 0. All right, so I'm going to build everything over. You might have another line of working in here, but you'll end up with 4x, y goes over, take away y, add 8, plus 4 equals 0. That's the equation, this one here, that's the equation of my median AM. Okay, now for the equation of the altitude. So we know an altitude goes through one corner and meets the opposite side, not at the midpoint. So this is not meant to be exactly halfway between A and B, but meets it at 90 degrees. That's the definition of an altitude. Through one vertex, meeting the opposite side at 90 degrees. So, how to get the equation of the line? Well, to get the gradient, I don't know the coordinates of this point. It's not that easy to work out at this point in the proceedings. So I'm going to say, well, I can work out the gradient of AB and then the fact that these lines are perpendicular. So, gradient of AB, MAB, again, changing y over changing x, 8, take away my minus 6, we're changing x, 1, take away 8, which is 14 over negative 7 equals negative 2. Quick check with the diagram. We're saying the gradient down here is negative 2. Yes, completely feasible. All right. Don't just plug that negative 2 into your y minus b equation, because that's not the gradient of the line we're looking for. And truth be told, when I was doing one of these the other day, that's exactly what I did. I was in such a hurry to finish the question that I just plugged in this gradient, didn't put in the perpendicular gradient. All right. We all make mistakes. Don't make the one I made. Perpendicular gradient, well, I'll write down what I'm saying, or method I'm using. I'm using the fact that I know that two perpendicular gradients, if they're perpendicular, must multiply to be negative 1. And so the gradient of the line I'm looking for, I'm going to put ALT for altitude. I think that makes it clear what we're doing, is, now I can either say if this is negative 2, I'm dividing both sides by negative 2, or I can go with the rule of thumb of flip it the other way up. Remember, this is minus 2 over 1, so it becomes 1 over minus 2, and swap the sign, becomes a half. Again, could this line be gradient at half? It's just a sketch. Yes, it could. Okay, so still writing it every time just so it's ingrained in my head. Y minus b, m bracket x minus a. Y equals, my gradient is going to be a half, connecting x and y values together, put in a particular point. Well, the only point that we do have is c as negative 12, negative 2. So, take away negative 2, x take away negative 12. I'd not immediately multiply out by the denominator here to get rid of it, but this take away negative each time is a little bit clumsy, so I'm just going to tidy that up first. Y plus 2 is a half, x plus 12. Now I'll get rid of my fraction, 2y plus 4. So we're multiplying both sides by 2. Multiplying the right-hand side by 2 cancels the divide by 2. So I just get left with 1 bracket x plus 12, which is, of course, just x plus 12. 2y plus 4 equals x plus 12. And since in my example up here, I went with, let's make it into this form of the equation, x's and y's and the number equals 0, I'll do the same thing down here. So this will be the ranging line in here, x minus 2y plus 8 equals 0. If you want a working line in between these two, that's absolutely fine. So that's the equation of the altitude. That's the equation up here of my median. And now we find where they intersect. The question says at point K. Point K on my diagram here. Okay, so I'm going to solve them simultaneously. From here, I could just write it like that, this one, for my first equation. I'm used to doing simultaneous equations with the number on the other side, so I'm going to rewrite it, just taking my plus 4, take away 4 from both sides. So I'll have equation 1, 4x minus y equals negative 4. That will be my first equation. That's my median equation. And likewise with the second one, I'll say x minus 2y, take away 8 from both sides, equals negative 8. So for here, x take away 2y equals negative 8. I'll call that equation 2. Where to go next with this? I could multiply this equation by 4. That'll give me 4x's, or I can multiply this one by 2 to make it minus 2y minus 2y. 6 and a half a dozen really, so I'll probably say I'll multiply equation 1 by 2. That gives me 8x, take away 2y equals negative 8. That's equation 3. If you wish, you can write equation 2 underneath here again, but it's right there, so I'm not going to bother with that. So remember, the secret to simultaneous equations, we must get a letter to disappear. So if I'm looking at equation 2 and equation 3, how can it get a letter to vanish? If I add them together, 9x, negative 4y, that still gives me x's and y's, no good. But if I subtract the two equations, minus 2y, take away the same thing, that's going to make the y's disappear. I'll have 0y, so that's good. So I'm going to say, all right, 8x, I'm going to do equation 3, because it's got more x's in it, take away equation 2. So 8x, take away 1x, 7x, minus 2y, take away itself, okay, will give me 0, or if you prefer to think of it as negative 2y, take away negative 2y, that's negative 2y plus, because take away negative is plus 2y, and that gives me 0. Either way around, I get 0y, which is what I wanted. Minus 8, take away negative 8. Oh, 0 here. That's okay, we're allowed to have an answer of x equals 0. So that's fine. Substitute into one of the earlier equations, from 1, 2, and 3, I would think, well, x is 0. Normally I'd probably say this has got small numbers for multiplying by, but look, it's going to give me 4 zeros here, so I'll probably put it into equation 1. It won't make any difference. Either equation will give me the answer, and indeed so would 3, but I'm just going for the one I think is going to be simplest. So I'm going to substitute into equation 1. So 4x minus y equals negative 4. 4 zeros minus y is negative 4. 0 minus y is minus 4, not negative 4. 0 disappears. Negative y is negative 4. Oh, y equals 4. Does that make sense in the diagram? We're saying x is 0, y is 4. Well, before that, I'll check. Always check, please, simultaneous equations. So I'm saying 4 zeros, take away 4. Left-hand side is negative 4, so that balances there. Yes, that works. 0, take away 2, 4. 0, take away 8 is negative 8. Yes, it satisfies both equations. So my solution of x is 0, y is 4 must be correct. Does it make sense in the diagram? We're saying this is a point 0, 4. Well, it's nearly on the y-axis, and it's definitely above here. And given that this is negative 12 all the way along, yes, that could well be 0, 4. So that I'm perfectly satisfied with that. So I'm going to say K, or point of intersection, K is indeed 0, 4. question like this is worth a lot of marks in the exam because we're working out a median. We're showing we know how to work out a median. We're showing that we must work out the midpoint. We're working out a gradient. We're plugging into y minus b equals mx minus a, and we're writing the equation in a standard form, either y equals mx plus c or x isn't y is the number equals 0. We've done that. Likewise on the altitude, worked out a gradient, showed we knew about perpendicular gradients, plugged into the equation, and then did simultaneous equations. So we're talking 9 or 10 marks here for working all this out. Can I also point out on here, perfectly standard way of doing simultaneous equations. If I'd so wished, I could have, for this equation here, instead of going to y minus 8 equals 4x, take away 4, okay, so 4x minus y plus 4 equals 0, I might have decided to say, actually, I would prefer to say y equals 4x, and then taking this minus 8 plus 8 plus 8, oh, that's plus 4, and write it in that form. This would have been just as acceptable. And likewise down here, when I got to this point here and then broke the brackets and then tidied the whole thing up, I might have said, actually, normally with fractions I do this, but because it's a half and I can deal with a half and it's going to go into 12 and all, so that's going to be nice, and go from this line and end up with a line from my equation down here, that this would eventually yield an answer of something like y equals a half x plus 4. It would be, because it would be 6 and then take off the 2. Sorry, half x plus 4. And then for my simultaneous equations, I could then have said, now I'm going to solve, oh, y is 4x plus 4, but y is also a half x plus 4. I'll substitute for this y with that because I know that y is also 4x plus 4. And then go down the line of saying 4x plus 4 is equal to a half x plus 4, and solve these. That is at the beginning of my solving my simultaneous equations. And that would work out just in exactly the same way and still give me the answer 0, 4. So in that case, it's your choice. And that's one example of how this all goes together. And that is our last note. So add it to your notes section, please, for straight line.